Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Potassium hydroxide, KOH, string test for bacterial differentiation. Table of content, Introduction to potassium hydroxide test, Objective to potassium hydroxide test, Principle to potassium hydroxide test, Method to potassium hydroxide test, Expected results to potassium hydroxide test, Uses of potassium hydroxide test, Limitations of potassium hydroxide test. Introduction to potassium hydroxide test. The potassium hydroxide, KOH, string test helps differentiate between gram-positive and gram-negative bacteria. The test works by exploiting the differential resistance of bacterial cell walls to 3% potassium hydroxide, KOH. During the test, a portion of a bacterial colony is mixed with a small volume of 3% KOH. If the bacterial cells lyse, the released cellular DNA makes the mixture viscous or stringy. A positive string test, characterized by the formation of a viscous string, indicates a gram-negative organism. Therefore, the KOH string test is also known as the string test. This test is a useful complement to other methods like the gram stain and the antibiotic disc test for differentiating between gram-positive and gram-negative organisms. Objective to potassium hydroxide test, to differentiate between gram-negative and gram-positive organisms. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Principle to potassium hydroxide test. The potassium hydroxide, KOH, test, similar to the gram stain reaction, relies on differences in the chemistry of bacterial cell walls. In the presence of potassium hydroxide, gram-negative cell walls are broken down. KOH easily dissolves the thin layer of peptidoglycan in the cell walls of gram-negative bacteria. The disintegration of the gram-negative cell wall leads to cell lysis and the release of cellular contents, including DNA. The released chromosomal material makes the bacterial suspension thick and stringy, resulting in a viscous solution that sticks to a loop when touched. Conversely, gram-positive bacteria are not affected by KOH due to their thicker peptidoglycan layer in the cell wall. As a result, gram-positive cells do not lyse, their DNA is not released, and no viscosity is observed. This test provides a simple and effective method to differentiate between gram-negative and gram-positive organisms based on their cell wall properties. Method to potassium hydroxide test. Place 1 drop of 3% potassium hydroxide solution on a clean microscope slide. Emulsify a few colonies of the suspect organism in the drop of potassium hydroxide to create a dense suspension. Stir continuously for 60 seconds. Gently pull the loop away from the suspension. Observe for any changes, noting if the mixture becomes thick and stringy, indicative of a gram-negative organism. Expected results to potassium hydroxide test. Positive result. The mixture becomes thick and stringy, forming long strands within the first 30 seconds. This result indicates the presence of gram-negative bacteria. Negative result. The suspension remains unaltered with no stringing observed. This result indicates the presence of gram-positive bacteria. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Uses of potassium hydroxide test. In laboratories where large numbers of cultures need to be processed, the potassium hydroxide, KOH test, can be used in addition to the gram stain for preliminary differentiation. It serves as a useful complement to the gram stain, providing a quick and effective method to distinguish between gram-negative and gram-positive organisms. The KOH test also complements the antibiotic disc test, offering additional information for bacterial identification and analysis. Limitations of potassium hydroxide test. Although useful, a negative KOH test does not conclusively prove that an organism is gram-positive. Older cultures, 48 hours, may turn positive after 30 seconds of mixing the bacteria in the KOH solution, leading to unreliable results. This is common with certain species such as Achromobacter species, Brucella melitensis, Pseudomonas paucimobilis, and Moraxella species. False positive results can occur due to using too heavy an inoculum, causing the solution to appear to gel but not string, inoculating with mucoid colonies. False negative results can occur due to using too little inoculum, preventing noticeable DNA-induced viscosity, using too much KOH, which can dilute the DNA-induced viscosity and make it unnoticeable. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!